In the video notes, we learned how to graph sine and cosine functions, and here in the class notes, we're going to get more practice at that with some more complex examples. And as is the case for most of the class notes, remember that these examples are important to really try on your own before you take a look at my solution. So just be in the habit of, before watching what I do, pause it, try to do it yourself, and then compare what we did to make sure that you got the right idea. All right, so remember we learned about the general form that we're looking for here, right? The absolute value of this A that's multiplying out in front is our amplitude. B tells us about the period. The period is 2 pi divided by that B value. H is the phase shift, so that's how far to the right you shift your trig function, and then K is the new equilibrium because that's how much we're going to shift up or down. All right, so let's take a look at example number 1 here. All right, so again, the thing we want to keep in mind is what regular old sine looks like, right? So you don't necessarily have to draw sine every single time, but it's good to make sure you have this image in your mind of sine starts at 0, starts by going up, then dips down to negative, right? It goes back to 0 at pi, and then back to where it started at 2 pi here. So the period is 2 pi from its starting point, we call it, at x equals 0. We're going to go up first, then down. All right, so you can see here that we've got 4 as our amplitude. Okay, but there's also a negative out in front. So we have A equals 4, but we also know that we have a vertical flip on our graph. And then in here, we can see that we're going to be shifted. And remember, when you horizontally shift, you're going the opposite direction of this symbol. So we're going to shift left pi over 4. And then finally, 2 is our B value, right? Which is telling us that the period is equal to 2 pi divided by 2. So our period is pi. Now you'll see that the graph here is unlabeled, and I'm going to try to keep graphs unlabeled, including on exams, because once you determine where you've shifted, what your period is, then that kind of informs where you want your tick marks to be. So what I'm going to do is I'm going to put negative pi over 4 right here. Since the graph has been shifted left pi over 4, then I know that this is going to be kind of my new starting point. All right, I know that because my amplitude is 4, I'm going to have to go up 4 and down 4 in the y. So there's 4 and negative 4. All right, and then so we're going to try to put tick marks every pi over 4. So maybe I'll label this negative pi, and then over here, so 4 of those pi over 4 tick marks give me positive pi, and maybe I'll go one more back this way. All right. So what we know is that we need to have a full period completed after pi. So thinking of negative pi over 4 as our starting point, when we add pi to that, that's going to be our ending point for a single period anyway. So, right, I think this is the start. And so, of course, that's negative pi over 4 plus 4 pi over 4, which is 3 pi over 4. So here at 1, 2, 3 pi over 4, I know that I'm back to where I started. All right, but then my knowledge of the sine function tells me that halfway through my period, I should also be back at equilibrium. So that puts us right there. So we've almost got it here, right? We know we need to get down here to -4, get up to +4, and we know that we're going to start by going down, right? If sine normally starts by going up, and we have a negative, we've vertically flipped, so we're going to start by going down. So I know that I'm going to be at my minimum halfway between these two zeros, and I'm going to be at my maximum halfway between those two zeros. So that's going to give me a good idea of what this thing looks like. All right, and then it's good to go ahead and just continue on with the tick marks that you can. And so if I go back 1, 2, 3, 4 pi over 4, that puts me right there. Halfway between those points, I'm back at 0 also. And then halfway between these, I should be up at my maximum. And halfway between those two zeros, I should be down at my minimum. That's probably sufficient in terms of how much we need to show of our graph. All right, so let's take a look at a couple on this page. All right, again, try this yourself first before you let the video continue to run. All right, so you probably identified a couple of things right away. So you definitely can see that we have an amplitude of 5, right? We have a vertical flip, much like in the last problem. And also this +2 out here means that y equals 2 is our equilibrium. Okay, or we also, of course, call that our midline as well. And I think that I used equilibrium in this set of notes, but I've also used, and I think our text has used the term midline. So either one of those is the same. Okay, so then so we can start to sketch some of this out right away. At least for the y's, I know that my equilibrium's at 2, and then I have to go up 5 from there. So I need to be able to fit at least 7 tick marks on this y-axis. And then we'll go down that many as well. Okay. And then it's not an official part of the graph, but I like to put just kind of a dashed line here at my equilibrium so that it's really easy for me to come back to this as kind of a home base. Okay. All right, so now the question is, what's happening with these x's? Now, if you said that your b is 2, and so therefore your period is 2 pi over 2, which is equal to pi, you'd absolutely be correct. The place that we can go wrong here is identifying the shift incorrectly. And so let's remember there are 2 ways that we can make sure we identify the correct shift. One way is to rewrite the argument of the cosine function so that any coefficient in front of the x is factored out. So it's only if you have a factored argument that you can see what the true shift is. And so that tells me that my shift is left pi. All right. Now there is another way to go about this, okay? So just like in the last example, when we said that we want to make sure we have an image of the basic sine function kind of burned into our mind, we also want to have that with the cosine function. So, you know, we start up here, comes down here, then it goes up there, right? And so here's our basic cosine function. So we know that its starting point is up at its maximum, and that happens at 0. So one thing you could do is you could set the argument 2x plus 2 pi equal to 0, and what you're going to do is you're going to solve for x to find your new starting point. Okay, so 2x plus 2 pi equals 0, 2x equals negative 2 pi, and then x is equal to negative pi. So what that means is that's telling you the same information that we got up here. Here we're saying shift left pi. Here we're saying that my new starting point is at negative pi. Either way, what we know now is we need to go to the left pi to start this thing. And we also know that our period is pi. So what I'm going to do is actually go all the way back here and put my negative pi right here, because then I could be done with a full period in this negative section, and then I could also do a full period in this positive section. Okay, so the new starting point is way back here at negative pi, but what have we done? We vertically flipped the cosine. So while cosines normally starts at its max, we're now going to start it at its minimum, which is 5 below where the equilibrium is. So there's my starting place. And then we know that we should be right back at that starting place after a full period. Halfway between these two, I should be at the opposite, at the max. So here at pi over 2, I'm up at the maximum of 7. And then halfway between these, I'm at the equilibrium, and halfway between these, I'm at the equilibrium. And so we can get a pretty decent picture of our graph here. All right, and then same thing over here, right? We're gonna be back there after our full period. Halfway between those, pi over 2, sorry, this should be negative pi over 2, right? But then at positive pi over 2, I'm up here at 7. And then halfway between those, I'm at 0. Halfway between those, I'm at 0. All right. All right, so let's take a look at one last example here. Again, try this yourself. Notice in here that this is not factored, so you're gonna have to find a way to calculate your true shift. All right. So again, they've thrown a vertical flip at us, right? And then we have an amplitude equal to 4. And then we have a midline, or equilibrium, however you want to say it, equal to -3. All right, so an amplitude of 4, midline of -3, so I got to be able to go down 3 and then go down another 4 from there. And then space our tick marks about the same up here. All right, and sketch in my midline. All right. All right, so now we got to look at our period. Well, our period, right, is going to be that 3 pi in the denominator of this formula, right? 2 pi over b. So I get a period of just 2/3. Okay. And then if I go with the route of factoring the argument, when you factor 3 pi out, oops, I meant to write 1/3 there. Let me fix that. When you factor 3 pi out, you have to say to yourself, 3 pi times what gives me pi? Well, that would be 1/3. So we can see that we are going to shift, and since it's minus, we're going to shift right 1/3, right? And if you would rather do the method where you say, let's set the inside equal to 0, and then simplify, you of course get the same thing. 1/3 is your new starting point. So you can see why it's nice to leave your x-axis unlabeled, because here we don't want multiples of pi like we had on the other ones, right? We labeled pi, 2 pi, pi over 2, things like that. Here, the period doesn't have a pi involved. The shift does not have a pi involved. So with 1/3 as our new starting point and 2/3 as our period, we should think about how often we want to show tick marks. So let's go ahead and put a third. Let's go ahead and put it right about here. Okay, so if that's a third, then there's 2/3, there's 3/3, and that's got to be the end of a period, right? So 1/3, 2/3, 1. And then we'll do the same thing over here. -1/3. Probably a little further, huh? -2/3 and -1. All right, so now we can set to graphing this. All right, so we've got the vertical flip, but it's sine, right? So sine starts at its equilibrium, right? Normally it would go up from there, but instead we're going to go down from there, but it's going to be back at its equilibrium at the end of the period, right? 1/3 plus 2/3 is 1. And then halfway between those, it's at 0. But because it's vertically flipped between these two, it's going to be down at its minimum. And between these two, it'll be up at its maximum. All right, and then we can do the same thing here. If I go 2/3 backwards, that's a full period. Halfway between, we're back at equilibrium. And then halfway between those, we're at the maximum. Halfway between these, we're at the minimum. And we can go one more here. And this one I definitely chose to show more cycles than necessary. Kind of your rule of thumb is, you know, I need to see at the very least one full cycle. It's nice if I see a little bit more. At least one full cycle, and definitely want to see stuff on both the positive and negative side of the y-axis.